Does a to the b equal b to the a, where a is one number and b is yet another number? For addition, the commutative property of addition exists. That is that a plus b is equal to b plus a. For multiplication, the definition of multiplication, at least for positive integers, is repeating addition. The commutative property of multiplication exists. That is that ab, which is a times b, is equal to ba, that is b times a. For exponents, the definition of using exponents for at least positive integers is repeating multiplication. Because addition has the commutative property, multiplication has the commutative property. Multiplication is repeating addition, and exponents use repeating multiplication, both of them at least for positive integers. One might ask, does the commutative property for exponents exist? That is, does a to the b equal b to the a? In this equation, you may notice the funny symbol with the equal sign with the question mark on top. I'm using this symbol to show I'm asking if a to the b is equal to b to the a. Does it? That's why the question mark is above the equal sign. I'll be addressing for this video for different real numbers a and b if a to the b is always, never, or sometimes equal to b to the a, and I'll explain why. I would like to share my outline so that you will know what I'm covering and in what order. First, I'll be giving the definition of a counterexample. I'll be considering the case of always, and then I'll be considering the case of never. So, what is a counterexample? It is an example that shows that a concept is not always true. It is an example of when the concept does not work out. And if it does not work out, then there is an exception, and therefore the concept cannot be always true. Note, this does not prove that the concept never happens. It only proves that it does not always happen. For a concept to never happen, that also does not leave room for exceptions. The counterexample is just one example of when the concept is not working. It doesn't show that the concept never happens. It may well, but the counterexample does not show that. So, does a to the b always equal b to the a? Well, let's discuss this case of 3 to the 5th power and answer, does it equal 5 cubed? 3 to the 5th power is equal to 3 times 3 times 3 times 3 times 3. We have 5 threes. We are using repeating multiplication. 5 cubed is equal to 5 times 5 times 5. We have 3 5s. We are using repeating multiplication. And 3 times 3 times 3 times 3 times 3 is equal to 243. And 5 times 5 times 5 is equal to 125. And 243 is not equal to 125. So, a to the b does not always equal b to the a. As there is a counterexample to a to the b is equal to b to the a, there is not a commutative property for exponents. It does not always work. So we know that a to the b does not always equal b to the a. But does it never happen where a and b are different numbers? Let's consider the following. We have 4 squared, and we want to know if it's equal to 2 to the 4th. 4 squared is equal to 4 times 4, you have 2 4s. We are using repeating multiplication. 2 to the 4th is equal to 2 times 2 times 2 times 2. We are using repeating multiplication. We have 4 2s. 4 times 4 is equal to 16. And 2 times 2 times 2 times 2 is equal to 16. And since 16 is equal to 16, 4 squared is equal to 2 to the 4th. So this counterexample means that it isn't guaranteed for a to the b to not equal b to the a, where a and b are different real numbers. A to the b equaling b to the a doesn't always happen, nor does it never happen. It sometimes happens. Thanks for watching this video, and I hope that you enjoyed it.